Hey YouTube, how's it going? A little update, what's been going on around here. I got a little update on my dashboard project. Been pretty busy at work lately. Had a little incident with the septic tank system here at the house about a week ago. Ended up having to do some digging. Kind of sets back a bit. But I've been trying to chip away on the dashboard project. I've also been helping out my buddy Mike on his bus on some stuff too. His remodel project and hot water heater installation and some other things. So there's been work going on behind the scenes, but nothing YouTube worthy quite yet. I'll show you a little view of my dashboard right now. So the most recent addition is these warning lights across the top here. So you can see I've got lit up red there: oil pressure, air pressure, generator, and engine hot engine light. And then the other ones grayed out over here are going to be turn signal, parking light, headlight, fog light. So I got to get that stuff wired up. I'll explain how I'm doing that. So this is looking down into my old analog dashboard. And the previous owner was kind enough to use these terminal strips. And these terminal strips, this side goes to the existing analog dashboard. This side comes from the bus. And they're all labeled. And so all I need to do is unhook the dash and hook up my 1 gauge sender to these lines here. I'm going to have to run them through this little guy first though. So this is a opto-isolator, and it's safe up to 30 volts on the input side, and on the output side it will switch, optically isolated from one side to the other. So this has got 4 channels on it, and I've wired the grounds together on this side, and I've wired the 5 volts inputs together on this side. So the way this is designed originally is to switch ground, and you can pull these jumpers off here, and then it doesn't switch ground anymore. It just closes the contact between these 2 points. So essentially what I'm going to do is I'm going to wire this side to the bus ground, and the senders, the warning lights, will come into the positive side of these. When they come on, they will energize one of these channels individually on this side of the opto-isolator. Then the other side, I'm going to wire the 5 volt input to the 1 gauge power source. And then, sorry about the camera focus here, I don't know why it's doing that. The output side will go to the corresponding inputs on the 1 gauge. So on the 1 gauge, you've got these channels, these input channels all over the place. Really, there's lots of them. There's dedicated ones for the turn signals and stuff that are 12 volts that I don't have to do anything to. But these ones over here are 5 volt. And I will wire from this guy to the corresponding inputs here. Then to connect it up over here in RealDash, you come in here, and I'll just show you one little example here. So like the low oil, if I click on this guy and I go into, hold on. If I go into inputs and values, and I can just say what the input source is, right? And so there's, in ECU specific here, there are channels there for those. And so those will get set to 1 when this receives 5 volts over here, and it will light up that corresponding light over here. So they're all red now because they're getting a 1 from somewhere. I haven't set these up yet, but yeah, that's the explanation of that. And just a second for you real data nerds out there, somebody who's done CAN bus debugging, RealDash has got a built-in CAN monitor, and these are the frames over here on the left, and this is an 8-byte data stream for each frame, right? And so 481 hex, and then these are all 1 byte value there, so those are all on. That is the 8 indicators saying that they're on, which is odd because they shouldn't be, and that's why those were all showing red on the other screen. So I'm gonna have to email the developer about that, and he'll fix it right away. Okay, scratch that. Part of that was wrong. Let me explain why. Okay, so the alarm schematic shows that the low oil, the hot engine, and the low air, just like the gauges, are completing a circuit to ground. So they're not going to output 12 volts. They expect 12 volts basically to be pulled low. So I had to redo those, the way that works. As a side note, something I really appreciate the previous owner of this bus did is when he made modifications to the factory wiring, he went ahead and noted what he did here. So like, instead of the really annoying loud buzzer that you have, there's a little piezo buzzer here. And he took out the door emergency telltale and the big alarm buzzer and stuff related to that. And he marks up on here when he changes stuff. So I think this is a good practice, right? And of course, these manuals, they stay with the bus, and there's all sorts of notes in here from him. If you go to a particular page, there will be, sometimes a piece of paper in there with some notes, or maybe a manual, or like a little instruction sheet from something that he added. So those first 3 bytes there on line 481, so now those are set high, and those will switch to 0 when there's an alarm condition. So on the Arduino, that's input pull-up is what that is. So that input will output 5 volts, and when it gets pulled to ground, that will switch to 0. So I can do the logic for that in RealDash. So what I'm doing here is I'm putting a diode in line for those alarm circuits with the negative line, or the black line, towards the negative, or towards the engine ground switch in this case, you know, and I'm just, you know, wrapping it in line, soldering it up, and heat shrinking it, and those will go in there to protect the Arduino from a potential 12 volt coming up that line, the opposite direction. That would be if something bad happened, you know, downstream. I know that there's some other circuitry in this, like the low air's got a buzzer on it. You know, if the ground was lost downstream of that, it could potentially try and, you know, send 12 volts up into the Arduino. So I'm just trying to protect against that. So I'm just adding a diode. So I've successfully, I believe, did you see that?
I did.
What was that, a rabbit?
I think so.
We got a lot of rabbits around here. Just out of the corner of my eye, I saw something run out there. It was in the shop. So I believe we've successfully unhooked all the wires from things here. And there's something snarled up here. Hold on. So this goes out here. Oh wait, that goes with this switch. So this, no, we left one, right? Because we thought, see, there's one left.
What's it to?
This terminal strip here.
Is it trans-temp?
Is that right? No. Yeah, there's still one more wire we got to get, damn it.
All right.
So we've successfully parted the sea of wires in my dash here. And so anything that's on the inside edge is staying. And anything that is out here, see, there's no wires crossing, right? And so
Pretty satisfied.
So what we're going to do here is we're going to pull these screws out, and we're going to take this dash panel off and set it aside.
Right.
Cool. All right, we did undo the screws. Let's see. Any wires left?
No, I think we're free.
Success. Wow. Piano hinge.
Yes, I have that.
Yep, that's a good way to do it. So that is a momentous occasion there.
Here's what you have left. Everything labeled. Nice.
So the stuff that's left there, I probably need to do some tidying up on, huh? Because there's a bunch of long...
We're going to stuff that stuff in there.
Right?
Yeah. All right.
Yep. Cool. Let's go work on your bus.
Okay.
Well, I took that box off my dash just to see what it looks like without something here. I gotta say, I like it quite a bit, you know, with those massive wires was not there. That's like, wow.